this lesson, we're going to be combining 3.1 and 3.4, focusing on building algebraic models and communicating with algebra. There are 5 learning goals. The goals are to define an algebraic term, to define degree, to define polynomial, to determine the degree of a polynomial and the degree of a term, and to model polynomials using algebra tiles. Okay, so we're going to focus a lot on terminology. First word that we need to learn is term. So a term is an expression formed by the product of numbers and or variables. And remember that product means that the two are being multiplied. So we don't need to put a time symbol between the 4 and this x cubed. We know that it's a product. It's being multiplied together. The x cubed is the variable. Okay? It's not important whether it has an exponent or not, but we look at it and see a letter, and we call that part of the term the variable. The number part of the term is called the coefficient. So the coefficient is 4, and the variable is x cubed. This term has a degree. So the degree of a term is the sum of the exponents on the variables in that term, only on that term. So this example would be degree 3, because that's the sum of all the exponents. There's only one exponent. Okay, this slide, I just want you to take a look. We're going to look at it again. You may already be able to guess what these prefixes refer to. So you have a polynomial, a monomial, a binomial, and a trinomial. Each of these matches with one of the words here. I'm going to get you to think about those on your own, and we'll check them in class together. Okay, and at the bottom of the slide, we need to copy down that the degree of a polynomial, as I said, we're going to focus on what polynomial means, but polynomial will have a degree that's equal to the degree of the highest degree term. Okay, and just to recall and go back a little bit, we talked about variables at the beginning of the year, and we mentioned that we can use variables to represent variables are used to represent an unknown value, and once we know what the value is, we can substitute it and evaluate it. So in this case, if x equals -2, this is what we know so far about variables. We can substitute and evaluate. Okay, when I look at this expression just from an algebraic point of view, without knowing the value of x, I can already mention that this is a binomial. And it has 2 terms, and the highest degree on any of the terms is 1. So there's an imaginary 1 exponent right there. Okay, so as I said before, we already know how to substitute. We replace things. You can use brackets for multiplication. I'll fill those in a second. A is equal to 4, so I put a 4 there, and B is equal to 1. And then we evaluate using BEDMAS. 4 squared is 16. 16 times 1 plus 2 minus 7. 16 plus 2 minus 7. 18 minus 7. And that equals 11. Okay? But once again, talking about the polynomial, I see that it's a trinomial. Trinomial. And if I look at all the terms individually, this term doesn't have an exponent. This term, the highest exponent is 1, or the sum of all the exponents is 1. And here, the sum of the exponents, 2 plus 1 is 3. So this polynomial, the highest term, has a degree 3. Okay, and lastly, we're going to look at modeling. So students often get confused when they look at these expressions as to why you can't just add 2 plus 1. So I need to show you what they look like if they could look like something. So this expression says I have 2 x's. So I'm going to model that with these bars. Each bar is an x, and it's positive. we have a set that are negative as well, but these ones are positive. So there's 2 x's and there's a 1. And this polynomial, again, we just keep refreshing, is a binomial of degree 1. And it's modeled with 2 bars that are colored in and 1 unit tile. This polynomial is a trinomial, so there's going to be 3 types of tiles. And the highest exponent on any of the terms, the highest sum of exponents is 2. Okay, to model it, we need to start with negative x squared. Well, x squareds are square tiles, and this one happens to be negative, so there's a negative x squared. Then we need positive 3 x's. So positive 1x, 2x, 3x. And lastly, negative 1, negative 2. These are unit tiles. It helps if students separate these into 3 individual categories and recognize that there's 3 different shapes, 3 different sizes, and that the coefficient tells you how many tiles and whether they should be positive or negative.